This question belongs to computer organization subject and was asked in GATE CSE 1992. So the question states, in an 11-bit computer instruction format, the size of address field is 4-bit. The computer uses expand opcode technique and has a 5 two-address instruction and 32 one-address instructions. The number of zero address instruction it can support is okay. So we have a instruction of size 11 bits. So what are the number of encodings? Number of instruction encodings possible. It is equal to 2 to the power n or 2 to the power 11, or we can say it is equal to 2048 instruction encodings are possible. Okay. It has a 4-bit address field. Now it is using expand opcode technique. 5 two address instructions. Two address instruction means we have address 1 and address 2. Let us suppose we have add register R1 to R2. So what it does, it adds R1 and R2 and stores in R1. This is a two address instruction. So how many encodings can be possible? Number of two address instruction encoding. We have 5 two address instructions. What is the size taken by one address? It's 4. So number of encoding is 2 to the power 4 because of one address and 2 to the power 4 because of another address. Like it will take 4 bit and it will take 4 bit. So total is 8 bit. So it is equal to 2 to the power 4 into 2 to the power 4, or we can write 2 to the power 8 directly. So the number of encodings are 1280 instruction encoding. Now we have 32 one address instructions. So let us suppose something like add A1, add R1. So is increment adds the value of R1 to the value of accumulator and stores it in accumulator. Okay, so number of one address instruction encoding equals to only 32 are there. Okay, and what is the size taken? We have an opcode and an address. So address size is 4 bits. So into 2 to the power 4. So we get it to be equal to 512 instruction encoding. So this total, let us suppose this is A. A should be equal to B plus C plus D. And what is D? D is number of zero address instruction encodings. So what is A? It's 2048. Total should be equal to 2 address plus 1 address plus 0 address. So D equals to 2048 minus 1280 minus 512. So what is it equal to? It is equal to 256. So number of 0 address instruction encodings are 256. So the answer is 256 0 address encodings. So what is a 0 address encoding? We just have an opcode and no operand is there. Like let us suppose we have an INCR instruction. If no operand is there, then the address is by implicitly defined in the instruction itself. So it will increment the accumulator value. Okay, so the 256 is the answer.